Welcome back everybody to Professor Seemo. This is a new video. It's a follow-up to the previous video where we wrote a node queue, a queue node-based queue, but it wasn't generic. This video is going to be a generic type queue, as it's not going to be as like there won't be much elaboration on how queues and nodes work as much as in the previous video. So if you are new to nodes and queues, I would recommend watching that video first, then coming here to see how generics are going to make it better for us. We will write it from scratch and with generics. Actually, nothing. The differences aren't that much. If you already understand how queues work and nodes work, you can just continue watching this video, and we will make it generic. Let's get into the video. Alright, let's start with the interface. Okay, to make it generic, wait, what do we mean by generic? Yeah, what we mean by generic is basically, as you have seen in the previous video, even if you didn't watch it, it's basically a queue. If it's not generic, it would be a queue with just a specific type. As we have said, nodes have values themselves, and each node in the previous video had the integer value. But what if I wanted to be a string? What if I wanted to be a string? What if I want that node to be an integer, then I wanted to change it to double later on? We won't be able to do that if everything is already written inside our code, like in the interface. So we have this generic type where we go to the name of the file beside the interface. Our class, just say E, or the general one is T. We'll use E for this video. And this is the interface. Just write public, as we have said. Enqueue has void return type. Okay, enqueue returns nothing but takes an item of value E. The type, as we said, is it an integer, a string, maybe some other type of classes? It's all possible. Public E dq public size stays an integer, of course. Alright, let's go to let's create another file. Let's call it Q generic. Alright, here specify that it's type E. Oh, also first let's actually write the node itself. Let's call it generic. Okay, here we'll specify that to be of type E. We have seen nodes. We have the value of the item itself, and the value of the item itself is going to be E, and public of type generic node E next. Then the constructor of generic node. Oops. Alright, that's going to be it's going to be taking an item, and this item is equal to the item, and this just next equal to null. And let's do the setters and getters manually. Public type E, get the item, return this dot Also, let's make the value of item final, since we won't be changing it. And we have the get generic node type e get next return this dot next. Right now, for the setter, it's going to be, we won't return anything, just void. Okay, set next. Set next. It's going to set next a generic node of type e. Let's call this next. Okay, so this dot next is equal to next. Yeah, we are done with our node. Now let's write our generic node queue implements queue. Okay, for this one we'll be using let's write it from scratch too. Let's write override public okay, see it from here, public void in queue. In queue is going to take type e. We have override public dq q. Did I spell dq? Right, perfect. And we have override. Override is used because of the interface. It's like an abstract type. Okay, and size. Let's do the size first. Turn and okay. Yeah, let's now start with the constructor and its variables. So we have, as you have seen before, we have the first type generic node. We have last type generic node public, and we have our size variable n. Okay, let's go to enqueue. So as we have seen before, enqueue if first equal null. Oh, let's set up the back equal null. Oh, sorry, it's last. Let's set up the constructor. Alright, so whenever we construct public generic queue, a generic node queue, sorry, generic node queue, we're going to have first equal to null, last equal to null, n is equal to 0. Alright, in the enqueue, if first is equal to null, last is equal to null, else at the end, so just we won't forget, return increment the value of n. Okay, else for enqueuing, store generic node queue, generic node old last, since we're adding at the back, is equal to last. Then last is equal to new generic node with item. Okay, then old last will be equal to, sorry, as it said, yep, we're setting the next of old last to last. And is that it? Yes, for this enqueue. Okay, now for dq. Let's see. dq, first we check if n equal 0, which which means the queue is empty. Return null, else, since dq is related to the front side in queues, store the value inside the first node, stored in a temporary variable. We'll call it temp. Okay. Temp first get item. Okay, what's wrong? Let's see. Cast to E. Okay, get item. Cast to E. Okay, what did we miss? Okay, no, this shouldn't be. Oh, okay. It's a node generic. Okay. Node generic. Oh, okay. Node generic. Oh, this has missed some stuff. Okay, first for this one. Let's type E. We have type E here. Yep. Alright. Sorry about that. Let's see, override method in Q to Q. Okay, let's see. In Q, dq size, implement Q. They are all in source, generic node. Oh, sorry. Oh, so, okay. And the Q itself, we forgot to give it type E. Okay, let's just in case our nodes should be of type generic node. We have missed some stuff. The name of the file is not QGeneric. That's why. Okay. Not Q generic. Sorry. Okay, not QGeneric. Generic node. Generic node. Let's try removing this one. Okay, let's back to E. Okay, temp first dot get item. This generic node. Let's see. Next, get item best item. Did we miss anything? Let's see. Generic node. In QE item, node Q generic. Alright, let's just continue, and we will fix errors later on. Alright. Now let's return the temp item. Oh, let's decrement before that. Right. Alright. So for this one, since we're dequeuing, first we store the value of the first item somewhere, then we set first equal to first dot get next, then check if first is now get next, which is the next item of first, which is another node, right? If that node is null, then just first dot null. As you have seen, wait, let's get back to generic node. Get next gets the next node, right? But originally, each node has a value of null and next. So if basically that was the only item, just set last equal to null. Since first is null, then the last item is null. Okay. Oh, if first equal null, let's put this code into the test. We'll see on the testing part. Alright, I have created this test file. Let's write these tests of type integer. See, this is what we mean by generic. We can have integers, strings, depending on whatever we want. It could be student, whatever we want. Okay, this is how powerful and helpful are generics. Let's see. Hopefully, we don't run into any errors. Okay, there is an error. Alright, let's see if we can fix it. Okay, let's take a quick look on our enqueue. Oh, alright, as you can see over here, last should be equal to first. Also, I just remembered why this isn't working. If we remove this, we can go to the declaration. Here, Java thinks that in the dequeue function, when I get item from first, it doesn't know that first has a type of integer or string, for example. So it is forcing us to cast it into type E. Alright. Alright, let's try running it now. Debugging. Okay, let's go to the test. At first should return the size. We have 1, 2, 3, 4. 1, 2, 3, 4, 4, 0 at the end after we dequeued everything. Let's try it again, actually. But now with string for example. String type. Okay. String type. Okay, see. Instead of rewriting the whole code, we can just Seemo magic, for example. Okay. Imagine having to rewrite everything again. See, we have Wasim, Seemo, Zainab, Majid. This is how helpful are generics. Hope you are enjoying this series, and hope you enjoyed this video. Hope you understood how we can implement queues, node based, and making them generic. And this is our first or maybe second video on data structures. Hopefully you're enjoying them and benefiting from all these videos. See you in the next video. Also, if you have a specific data type that you want us to cover in this playlist, leave it down in the description. There are a lot yet to come, and we'll see you in the next video. Bye bye.